Hey, hello guys, welcome back to my channel Data Science with Gagan. Yes, it's been a long. I haven't uploaded any videos on data science projects, but yes, I am back with another data science project video. And in this video, I'm going to share a computer vision project where we will see how can we use YOLOv11 model, which is the next model of YOLOv10 for object detection, and then we'll see how it works and how its architecture looks like, and then how can we use it for inferencing part, and then later on we'll see um, how can we train this model on our custom data set, and then we'll train that model, and then post that we'll use that model for our inferencing part. Okay, yeah, as I was telling, this is going to be the content for this video. First we'll see something about YOLOv11, what is this model, right? And then we'll see something more on its architecture, how it looks like, and then we'll see how it is different from other YOLO previous models. Okay, and then we'll do some inferencing using pre-trained models, because there are multiple versions of YOLOv11 model out there in the market, which are YOLOv11N, which is nano, and then we have M, which is medium, then we have S, which is small, then we have L, which is large, and then we have XL, which is extra large. As we move from N to XL, the sizes of the weights gets increased. Okay, and then once we will do all the inferencing using the pre-trained model, then we'll try to train a model on the custom data set, where first we will collect some images, and then we'll do annotations, right? And then we'll pick up any model from NMSLXL, and then train that model on the custom annotations that we have created on our image. Okay, so let's start with YOLOv11, where we will see what is this model. Okay, so YOLOv11 is a deep learning based object detection algorithm, and it is the latest iteration of YOLOv series, and it is mostly used for real-time object detection purposes. And if you want to learn something more in deep about YOLOv11 model, then you can go to the Ultralytics website. As you can see here on the screen, I am sharing the Ultralytics website page, and on the screen you can see that YOLOv11 model is not only specific for the object detection purpose. You can use it around multiple tasks like image segmentation, pose or key point detections, oriented detection, and for classifications as well, which says that it's a multitasking model. And if you guys want, I'll share this link with you all, so you can check my description of this video, where you can find the link for this website. Okay, and now we will see how its architecture looks like. Okay, so basically its architecture is having three major components, which are backbone, neck, and head. And as you can see, same thing in this image, that I told, it's having three major components: backbone, neck, and head. And all of three components are having their different functioning. And here, basically, the output of the backbone goes to the neck component, and neck component's output goes to the head, and the final output yields via the head component. Okay, so when it comes to backbone component, here YOLOv11 uses the CSP dark PEP backbone, which is cross-stage partial darknet with parallel aggregate path, which is the enhanced version of CSP darknet series. Okay, now let's come to neck component, which is a feature extraction component. So here model features uses an enhanced SPP, which is spatial pyramid pooling, with parallel aggregation of improved feature extraction. Okay, now let's come to the final component, which is head component, which yields the output. So it use here the model head utilizes a decoupled head with separate branches for object classification and bounding box regression. Okay, so this is the architecture of YOLOv11, which is consisting of three major components: backbone, neck, and head. So let's see how it is different from other YOLOv models. So I have mentioned three major points which makes it different from other YOLOv model, like from the previous V models. Okay, so first one is improved feature extraction. As I told, or as I mentioned in the architecture part, right, it uses the enhanced version of SPP in the neck component, right, for feature extraction. And then we have better classification because of decoupled head in YOLOv11. As I mentioned, in the head component, it uses decoupled head, right? And then third one, we have efficiency, which is optimizations for faster inference. So all of these 3 points makes it different, or makes it more reliable, or makes it more better than other YOLOv models. Okay, so now let's have a look. How can we do inferencing using any pre-trained model? As I mentioned, right, we have multiple weights or multiple versions of YOLOv11 model, right? So we have nano, small, medium, large, and XL. So what we will do, we will pick one of those models, or what we will do, we will pick all of those models and we'll try to do inferencing on that. Okay. So let's start with its inferencing. So as you can see on the screen, first I'm importing all the required libraries like supervision, CV2, ultralytics. So we need CV2 to get or to read the images or to read the video. Okay, and then we have a supervision, we use supervision to visualize all the things on the image. Like if I want to draw a rectangle and all the detections on the image, then we can use this library to supervision. And in alternate, what we can do, we can use CV2. Like CV2 also provides so many functions to write something on image, to draw something on image. So using CV2 as well, we can draw all the detections on the image. And we'll see in this video, right, how can, how it is different from each other, right? And then we will use ultralytics to read the models, right? And now let's see. So here in the third cell, you can see first, wait, let me run it first. It's taking quite time. So now let's read this model. So what you can do, you can download the weights from the official website, which is ultralytics, that I have shared in the description of this video. Okay, so what you can do now, once you will load this weight, now let's say an example, this image I am going to use for the predictions. Okay, so what will happen when I will pass this image to this model? What it will do, it will return me a detections, whatever it has detected on the image. If there are multiple objects, then the list of the object detections will be there. If there is none, then it won't return anything. If there is any object, then it will return at least a detection for that particular object in that image. Okay, let's see what it returns. So first time it might take a time to run, but whenever you will run it the second time, it won't take much time to run. Okay. So once we will feed this image to a model, or while reading the videos, when we will feed the frame to the model, then it will return a result. So let's have a look how its result looks like. Okay. So here on the screen you can see, right, I have printed two things. One is model.names. So what model.names are all the classification on which it has been trained. Okay, and then we have a result 0 dot boxes. So these are the predictions from the model. So here in the screen you can see, right, it has returned this thing in the result. So first one is class, what class it has detected. So you can see it has returned 2, which is car. Here you can see in the dictionary, right? Then we have a confidence score. So you can see it has returned like it is predicting car with 92.4 confidence score. Okay, and then we have IID and SPREC, which these are used when we are tracking the video using ultralytics. Okay, if any object is detect is SPREC, then we will see it, is tracked as true, and it will also return an ID for that particular object. And then we have these three things, right? XBWH, XBWHN, XYXY, XYXI, and right. So these are those things, right? Basically, XYW means, your center and your width and height of that particular bounding box. And then we have xy, which is top xy and bottom xy, right? So it returns all of those things. Now it's on to you, like whatever you want to use, you can use some from them. Like if you want to use xyws, then you can use xyws. If you want to use xyxy, then you can use xyx. Okay, so now we got these predictions over this image. So now let's try to visualize it, right? So as I told, right, we can visualize all the detection on the image using cv2 and as well using supervision. So I have used both. So let's plot all the detections using cv2. So what you can see, right, you can see here, like this is the bounding box that the model has detected around this object, which is car, right? Now when you will click on when we will run this one, you can see it has detected car, right? So right, so like board does the same thing while visualizing the detection on the image, right? So now what we will do, we will pick all of the models from end to excel, and we'll try to do inferencing in the live video. Okay, so let's see. So yes, let's do some inferencing using pre-trained model. So first you can see that I am using 11n, which is nano model. Okay, I have loaded this model. Now let's see how it predicts. Okay, so you can see it's predicting me as a person, and my couch is couch. But you can see, right, the bounding box for the couch is not quite stable, right? So let's see, like if I get other object, whether it detects. Okay, so like you can see, right, I have a remote, but it is confused between cell phone or remote. Listen out, so okay, it's predicting bottle is bottle. Nice. Okay. Okay, now it's quite good, right? So what we will do now, let's switch this model to to S, and let's see how it predicts. Okay, you can see right now the small model is not quite good. It's assuming the single couch as a two couch. And now let's see. Okay, now but it's predicting remote as remote, not as cell phone. Now, okay, bottle is bottle. It's quite good, but it's somewhere confused with this couch. But it's quite good, right? Now let's try the medium model. It should predict good. Yeah. Now you can see, right? It's predicting couch quite stable. And let's see. Okay, bottle is good. Um, remote, yeah, it's quite stable with remote as well. But it's good right now as compared to previous models. Nano and small, it's predicting quite good and stable. Now let's try with large. Now it's loaded. Now let's see. But what will happen as you will go towards the higher model, the video inferencing timing will get slow because the higher model is having the higher weights, right? Large weights, right? Now you can see here that it's predicting couch as couch with good stability, right? The bounding box is not moving so much. Bottle, remote, okay, but okay, it's predicting all together in a nice way. So it's better than the previous model. Now let's try with Excel. It might be a slow, but let's try. Yeah, but if we are having a good configuration in your in your system, right, so it won't take much time. Okay, what's when? Okay, we don't have. Let's check whether it's there or not. Okay, it's X now. So, okay, yeah. Hi. Yes. Yeah, like somewhere it's confused between remote and cell phone, but everything it is predicting apart from this remote in quite better way, right? and which is much accurate and stable. So now what we will do, I'll collect some household things, and I'll try to detect them using YOLOv11 Excel model, right? So yes, let's see. Now let's see how it predicts. Okay, you can see. Yeah, like it's quite a way plotted point plant, right? But it's predicting them quite well, and it's somewhere confused with this table, right? And now let's have, now it's predicting laptop and that couch. Yeah, it seems to like a bed. I should predict bottle, remote. Yes. Okay, what? Okay, it's predicting tab as a book. If what if I open this? Okay, it's predicting as a laptop. Okay, nice. And what is predicting? Okay, it is predicting quite good, right? But it's nice. So since we are done with the inferencing part, where we used multiple models of YOLOv11 from ranges from small to extra large, and we saw their performance, how they are detecting the objects in the live video. But the most curious question is, can we train any of those model on a custom data set? uh, so answer is yes, we can train any of those models. Models means YOLOv11 models, any of them, either it is X, large, medium, small, or nano, on our custom data set. So what we'll have to do, we will have to create on our data set. So for that, either you can go on Google and search some images and download them on your local machine, or you can click some images by your phone or camera, and then once you will collect all those images, what you will have to do, you will have to do a notation over them. So there are a number of platforms available on Google, on which you can do the annotation things. Once you will do the annotation things, you can export them in the form, in the YOLOv11 format. Once you will export them in the YOLOv11 format, then you can train the YOLOv11 model, any of the version you can train, right? And then you once you will train the model on your custom annotations, then you can use that model for your inferencing. Okay, so let's see how can we do it. So for the training purpose, we will have to collect some images, right? So either you can collect the images from the Google, or you can capture some images through your camera or phone. So what I have done so far, I have collected some images through my camera. Here in the screen you can see, right, the that I'm capturing two objects, which are bottle and remote. And you can see that I have taken all the images at different angles, at different distances for both objects, right? So once we will collect all those images, we will have to create the annotations, right, for all these images. So for the annotation purpose, you can use any of the annotation tools which are out there in the market, but I'm using RoboFlow. It's quite efficient. If you want to use RoboFlow, I'll share this link with you guys in the description of this video, so you can find it there. So once here in the screen you can see, this is the RoboFlow interface. So here in the screen you can see we have a button to create new project. So once you will click on this new project, it will ask you to give the project name. So I'm giving it as a demo, and one class name. So I'm giving as bottle, because one of the class that we have as bottle, right? So once you will click on it, create public project. So it will ask you to upload some images. So let me show you how, right? So so computer vision project YOLO11. So here you can see we can upload the folder directly. So let's see. So here you can see all the images are here, right? So save and continue. So here you can see, like, it has annotated all the images using auto label, right? Right. Start auto label, generate test result. Okay. So now it's annotating all the images, and once it will done, I'll show you how it will look like. If you want to correct any of the mistakes, then you can do it here. Once it will get annotated, so it's processing. Let's see. So as you can see here, we have 39 images, right? And it has annotated all the images, but it's just producing the result. So let's see what it will give in the result. So let me tell you, like, what other tools you can use for annotation purpose. So we have CVAT and we have multiple tools. You can use any of them. It is not mandatory that you will have to use RoboFlow for annotation purpose, because it's quite efficient. Once you will annotate all the images, it will give you the functionality of augmentation purpose, where you can modify some images and create more images out of these images, which you will give to this annotator. And also you can set the partition, what partition you want to keep for training purpose, what partition you want to keep for test and validation purpose. You can do it here. And also it gives you the functionality to export the data in the required format that you want, right? So that's why I'm using the RoboFlow, because it's quite efficient as compared to other ones. So here you can see that it is asking for the reviewing. Let's do it. So once we will reach here, we will have to approve all the annotations. Once we will approved all the annotation, we will get this option, add approved to dataset. When we will click on this, as I was telling, right, like, we have an option to segregate this data into train, test and validation. So we can set the percentage here. So it by default it is 70, 20 and 10, and if you want, then you can change here. As I want keep 80% for training and 10% for validation, right? So once you will click, you will then click on add images. So as you can see, right, our data set is ready. Once you will go on data sets, right, what you will see, yep, right. Once you will click on generate version, right. So as I was telling, right, there, here we can have here we are having a multiple steps of pre-processing and augmentation. So we don't need to do anything in pre-processing. Just click on continue. In augmentations, you can add what kind of augmentation you want to do on the current images. As you can see on the screen, we have a multiple options. We can flip, we can rotate the image, we can crop the image. We can do multiple things here. And so anything you want, you can do it from here. So I'm not going to do anything for as of now. Just continue, create. So as you can see here, right, we show 31 images are there for training purpose, 4 images are there for validation purpose, and 4 images are there for the test purpose, right? So now our data set is ready. Now what we'll have to do, we will have to download this data set, right? So as I was telling, right, we can select any format that we need. So we want for YOLOv11, right? So here we have two options. One is we can download the zip directly, or we can directly import this data, sorry, this data into our code using this code. Once you will click on code, because I'm going to do it through code. So as you can see, right, just copy it from here, done, right? So we have taken that code from the RoboFlow, so we can import the data from RoboFlow to our code. So right, and this is the code. So now what we'll have to do, using that code, we will import the data into our local machine, and then we'll start with the model training. So for that purpose, we need this Ultralytics library. So I'm configuring it, so let it install. So now it has been installed. So, and also to access RoboFlow, we will have to install RoboFlow. So let's install it. And also here you can see, right, using my API key, I am downloading my dataset here, YOLOv11, and now it has been downloaded. You can see here demo 1. Now dataset dot location, right? Just copy it, because we need to change, because we need this location, because we will have to edit data.yaml file into this folder. Now the thing is, before we will do it, we have to select the we will have to select the model, which model we want to select, which model we want to train. So here I'm selecting small model. It's a small model and it won't take much time while training. So now let's change this YAML file. Just put just save it, and same thing. It's in the content. Now we have loaded this model from the hub, and here I'm giving these parameters, like I want to train my model on 100 epochs with this image size. Now let's run it and let's see what it returns. Now here you can see, right, it will create a run folder. Inside the run folder we will get our trained model, and once it will train, you can download your model from here, and once your training will start, it will look like this, right? So now let's switch to the inference part. Okay. So I'm done with the training part, and also I have downloaded all those trained weights onto my local machine from Google Colab, and I'm using here. And here you can see I have loaded those train weight, and I'm checking out those evaluation metrics, how how well it is doing. And also you can see on the screen, these are the number that I'm getting from my model, and it is giving around 99.5% accuracy on overall MAP 50 and MAP 75. Okay, now let's have a look how how this model is detecting the objects that it has been trained on. So okay, let's start. So here you can see, right, it is detecting portal as portal and remote as remote. And also what you can do, right, even though you can increase or you can improve this model accuracy by training model on more images. Like for now I have captured image for each object, where I have kept one object in an image only. But what you can do is, you can keep multiple objects into an image and you can annotate them, right? And that thing will help out the model to improve its performance. But here you can see it is doing good, right? It is detecting remote as remote and bottle as bottle. So I guess it's good, right? It's quite good. It's detecting bottleless water from the near. So that is all about this video, where we saw and where we studied about YOLOv11 model, like how it is different from other models, its previous versions, and how it works and how its architecture looks like. And also we did some inferencing part using pre-trained weights at each version of its. And also we tried to train this model on our custom dataset, and we did it. And also we did the inferencing part on our trained model. Yeah, so that's all. I'll see you in the next video, where we will do something more on YOLOv11 model, because it's a multitasking model, right? It can do a segmentation, it can do a classification, right? So let's see how it does in the next video. So see you guys in the next video. Bye.
To keep me motivated for more videos on data science projects, please do like and subscribe. And please do not forget to press bell icon for notification of new projects videos.